to be moving into proving things when we have given statements. So here we go with geometric proof part 1. We have a little flow chart here, and it's going to take us through the steps. And so where we start is always the hypothesis. We have a hypothesis, so the if. So if this is true, then something else can happen. So we're going from the if to the then. And in the middle here somewhere, there's reasons why we can do things, okay? Reasons why we can say stuff. So the reasons are the justifications. We can use definitions. We can also use postulates. We can use properties. And we can use theorems. So, these are our justifications. Why we can do what we do. This is the why. That's the why. Why we can do what we do. Okay? We're using deductive reasoning in these proofs. We're putting things together to figure out what's going to happen. Let's look at a couple of examples. We need to remember that you must justify each step. I put it in its own slide because we have to give reasons why we do what we do. So, we have to give reasons why we're doing what we are doing. Okay? And so what it looks like is this. This is a sample outline proof, and it's a sample giving us everything that we already need. We're just going to write the reasons. Okay? So we're going to write a justification for each step, given that A and B are complementary. Okay, so given that one thing and another thing, okay? A and B are complementary. This is a given. So here's our reason. That's given, okay? If you want to number them, that would be perfectly all right. So let's look at number 2. Number 2 says the measure of angle A plus the measure of angle B is equal to 90. We need to know why we can say that. If we look at the previous step, it says A and B are complementary. Well, what does complementary mean? It means that they add up to 90 degrees. And so the reason why we can say this is that's the definition of complementary. That's the definition of complementary, is that they add together to equal 90 degrees. So when we go down to 3 here, we need to figure out why we can say what we say. Here's the pattern. If I look at this step, I'm saying angle A is congruent to angle C. I'm going to look at the previous step. Does the previous step tell me why I can say this? No. So it must come from somewhere else. And I look up here and I see that it's already up here. And so this is another one of our givens. Okay, that's the reason why we can say that. Okay, so once again, remember, these justifications are coming from given information, theorems, definitions, postulates. Okay, so when I look at 4, 4 is saying the measure of angle A is equal to the measure of angle C. I'm going to look back to the previous line. Are they related? They are related. They both say that the two angles have the same measure. Well, this, to me, is just definition of congruence. Because look, it's saying that the measures are equal. Well, we know that's true because that's what congruent means. That's what this means. Okay? Now, step number 5. We look here and we see, how is it related to the previous line? Measure of angle C plus measure of angle B is equal to 90. Why can we say this? Well, let's look back up top. We might have to look back again. I've got measure of angle A plus measure of angle B. Now I'm saying C plus B. Well, if we look somewhere in the middle here, and I know I've got a lot of arrows going on, so let me erase a couple of them. we're looking to see how things are related to one another. Well, look, if I take this line and I use this line and this line, and I say, oh yeah, A is equal to C. So now I can say C plus B is equal to 90. That's substitution. I substituted angle C for angle A. Now if I look down the bottom at 6, I'm looking at my previous line. How are they related? Angle C and angle B are complementary. Well, duh, because C plus B is 90. So to me, that is definition of congruence. Sorry, complementary. Definition of complementary. Okay? And so this is meaning that these are complementary. Okay, definition of complements. So that's how this rolls. That's how we go on this little proof trip. We justify each statement as we say it. And so when we move on to this next one, you're going to be doing this one. You are going to be looking at what it means to justify each statement. Okay? So pause here, see if you can do it. I'm going to go right through it. Remember, these are the justifications. So in 1, B is the midpoint of segment AC. Well, I don't have a previous line to refer back to, so I need to refer to up here. It says B is the midpoint, so that must be given. Okay? Let's look at 2. Number 2, segment AB is congruent to segment BC. Why can I say this? Well, let's look. B is the midpoint of segment AC. I'm going to draw a picture here. So this is saying B, and because it's the midpoint, we know that those two sides are the same. So B is the midpoint of segment AC. Well, if I think about this logically, I'm given that B is the midpoint. So if I think about segment AB being congruent to segment BC, that's the definition of midpoint. Okay? I'm justifying this by saying the definition of midpoint is that B is the midpoint. Okay? B is the midpoint, so both sides must be the same. If I look at 3, in 3, I'm saying that segment AB is congruent to segment EF. I look at the previous line. Is it related to that? Sort of, but EF is a new player. So I must have to look up here. Oh yes, that is a given. Okay, so that's given. Now when I look at 4, we're going through a logical progression here. If B is the midpoint of segment AC, and segment AB is congruent to segment BC, and I've also said that segment AB is congruent to segment EF, I'm going to try to say that segment BC is congruent to segment EF. Well, look at what happens here. If I've got AB congruent to BC congruent to EF, all I'm doing here is I'm saying, forget about this. Forget about this BC part or this AB part, because I've already said that they're congruent. So this is going to be transitive property. Of congruence. Because if I'm saying that two things, EF and BC, are both congruent to AB, I can say AB's out of the picture now, and I can put those two together using the transitive property. Okay? That's the introduction to proofs. That's Geometric Proofs 1. Enjoy. We will see you tomorrow.